How does quantum hardware differ from classical computer hardware? Have you ever wondered what sets quantum hardware apart from the classical computers we use every day? Let's break it down in a way that makes sense. First, let's talk about how information is stored. Classical computers use bits, which are like tiny switches that can be either off or on, representing 0 or 1. These bits are built using silicon transistors. On the other hand, quantum computers use qubits. A qubit can be both 0 and 1 at the same time, thanks to a property called superposition. This allows quantum computers to handle many possibilities at once. Now, how are these two types of hardware physically built? Classical computers relying on silicon-based technology, where transistors switch electrical signals on and off. They usually work well at room temperature. Quantum computers, however, use systems like trapped ions or superconducting circuits. These systems often need to be extremely cold, close to absolute zero, to keep the qubits stable and functioning properly. When it comes to how they process information, classical hardware follows the rules of Boolean algebra. This means operations are straightforward and deterministic, with each bit being clearly defined. Quantum hardware, in contrast, operates on principles of quantum mechanics. It uses superposition and entanglement, which allows qubits to influence each other instantly, even when separated. This leads to a different way of computing that can produce probabilistic results. Next, let's consider power and scalability. Classical hardware's power increases linearly as you add more bits. For example, doubling the number of bits roughly doubles the processing capacity. Quantum hardware is a different story. Its power scales exponentially with the number of qubits. For instance, with n qubits, a quantum computer can representing to raise to the power of n states at once. This means it can tackle complex problems much faster than classical systems. Energy consumption is another area where these two types of hardware differ. Classical computers use energy based on how quickly the transistors switch, which can generate heat. Quantum computers can perform certain tasks using less energy because they manipulate quantum states without the same energy costs. However, they do requiring special cooling systems to maintain their quantum states. Stability is also a key factor. Classical hardware is generally stable and reliable, with well-established error correction methods. Quantum hardware, however, is very sensitive to noise and environmental factors. It needs complex error correction techniques to keep the qubits functioning correctly. Finally, let's look at their applications. Classical computers are versatile and can handle a wide range of tasks, from everyday computing to data management. Quantum computers are more specialized. They excel in areas like cryptography, optimization problems, and simulating quantum systems, which classical computers struggle to do effectively. In summary, quantum hardware and classical hardware differ in how they store and process information, their physical implementations, computational principles, scalability, energy efficiency, stability, and applications. Each type of hardware has its strengths, with quantum technology opening doors to new possibilities in computing.